Dear students, myself Dr. M.K. Goyal, Department of Applied Science and Humanities. We shall take the lecture of Statistical Technique, lecture number 2 of BS 302 code, Mathematics 3rd. The topic of our lecture is regression analysis. We shall cover up the lecture on regression. Regression means impact of x on y and y on x. If there are two variables, then x on y is impact with y on x is studied on regression. Regression analysis is the based of correlation analysis. Correlation analysis determines the nature and the degree of correlation between two variables. It is essential there must be two variables, if x and y or y and z. There must be two variables. Thus, it is enabled to us to measure how much strong is the relation between the variable, but it does not provide the exact mathematical relation between them. The correlation analysis determines the nature and degree of correlation between two variables and does not provide the exact mathematical relation between them. But the regression is the estimate of prediction of unknown variable to the other one variable from to the known value for the another variable. That is, if x is known, then x is to be calculated with the help of regression analysis. If x is known, y is calculated. If y is known, x can be calculated. That is based on regression to estimate the prediction of unknown value of one variable from the another value is called study in regression. Regression analysis enable us to determine the functional relationship between two or more related variables. It is essential. That means we have to establish a relationship between two variables and more than two variables. That may be studied in the regression. It is to be noted that just like curve fitting, here also the form of the function should be known by least square method. That means in the curve fitting we have to use the method of least square. We can find the value of constant to obtain the curve to best fit. That is, if x is given, y is to be fitted by curve fitting. Of the curve fitting and regression is that the regression any of the variables may be considered as independent or dependent, while in the curve fitting one variable cannot be dependent. That means it is essential that curve fitting one variable cannot be dependent. Now we shall study the linear regression. Linear regression attempts to model of the relationship between two variables by fitting a linear equation in the observed data. Let us take the example. We can relate the weight and individual of their heights using a linear relationship with the known of linear regression. If height and weight is to be calculated, if height is given, how much weight is to be there. Similarly, if weight is there, how much height must be there? How much height must be there? That means we have to study, we can relate the weight and is an individual of the heights using a linear equation is known as linear regression. In case of line of regression, there is the calculation of xi, yi. I is equal to 1 to n. That means x1 y1, x2 y2, x3 y3, x4 y4. These are the y variate data. We have the no relation. For justification to assume y as a dependent variable and x is independent variable. Here x is independent and y is to be calculated with respect to x. That is called dependent variable. Either of the two variables are estimated for the given values of the other. Now, the value of the y is to be estimated by the value of the given values of x. We have the relation y is equal to a plus bx, where a and b are parameters. A and b are parameters is called a regression line of y on x. Y is equal to a plus bx is known as regression line of y on x. Here a and b are parameters, which is to be find out. For various values of x, we have to calculate the value of y. And we have to establish the relationship with the relation y is equal to a plus bx. To find the best estimation, we have the relation for this. Similarly, if we change the variable x and y by in terms of the values, we wish to estimate x for the given values of y, we have the relation x is equal to a plus by. Here y is independent variable. X is to be calculated. Then equation is called x is equal to a plus by. That means if you have to find out the value of y and x are given, then you must have to apply y is equal to a plus bx, where a and b are parameters. Similarly, if values of y are given and x to be calculated, then we have the relation x is equal to a plus by, and a and b are also parameters. यहां पर x गिवन है, यहां पर y गिवन है, x की गिवन वैल्यूज के लिए y निकालना है, तो क्या कहलाएगा? रिग्रेशन लाइन ऑफ y ऑन x. यहां पर y की गिवन वैल्यूज के लिए x निकालना है, रिग्रेशन लाइन ऑफ x ऑन y. Now regression line of y on x is given by y minus y bar byx, x minus x bar. Regression line of y on x. Here byx is the coefficient of regression. Regression coefficient of y on x, that is called byx. Here y bar is equal to summation y by n, number of sum of the values of y divided by number of terms, that is called y bar is equal to summation y by n, and x bar is equal to summation x by n, having the values of sum of summation x divided by n, that is called x bar, and byx is equal to this. Byx is called a coefficient of regression, and byx is to be calculated by the formula n summation xy minus summation x summation y divided by n summation x square minus summation x ka whole square. That is the calculation of regression coefficient of x and y. We have the following values of x and y are given. X and y are given. Then we have to establish summation x here by summing of these values. Summation of these values, that will give summation y. Here summation x, summation y. Then we have to calculate x square. Summation x square is to be calculated here. X and y, that is also here. And putting these values in this relation. This is the regression coefficient of y on x. It is also known as R sigma y upon sigma x, standard deviation. R is the coefficient of correlation. Byx Byx is also known as coefficient of correlation. Byx is equal to R sigma y upon sigma x. Standard deviation of y sigma x, standard deviation of x. Similarly, regression line of x on y is given by x minus x bar, bxy, y minus y bar. Here bxy is the coefficient of regression coefficient of x on y. Regression coefficient of x on y. अगर y given है, x निकालना है, we have to apply x minus x bar, bxy, y minus y bar. Here summation x bar is equal to summation x by n, y bar is equal to summation y by n. Putting these values in this relation. Similarly, the coefficient of regression coefficient of x on y having the relation bxy is equal to n summation xy, summation x summation y, n summation y square minus summation y का whole square. Here the terms are given as x and y. Then we have to calculate the terms in according to this. X, y. Then we have to calculate summation x, summation y, xy, y square, and then summation y square, summation xy. N is the number of terms. And bxy is the r summation x upon sigma x upon sigma y. R is the coefficient of correlation. Sigma x is the standard deviation on x. Sigma y is the standard deviation on y. There are some properties of the regression coefficient. The first property is correlation coefficient is the geometric mean between the regression coefficient. The coefficient of Byx is equal to R sigma y upon sigma x. Similarly, Bxy is equal to R sigma x upon sigma y. After multiplying them, Byx into Bxy is equal to R square and summation y upon sigma x upon sigma y is to be cancelled out. And that is become R square. Byx, Bxy is equal to R square. And geometric mean, that is become R. The correlation coefficient of the geometric mean between two regression coefficient, this and this, are equal to R, coefficient of correlation. Second property is the one of the regression coefficient is greater than unity and must be less than unity. If one of the regression coefficient is greater than 1, then other is less than 1. That means if Byx is greater than 1, then Bxy is less than 1. Third property, both the regression coefficient and the correlation coefficient must have same sign. That means the regression coefficient and correlation coefficient have same sign. That means if R is positive, then regression coefficient BYX is also positive. R is negative, BXY or BYX is also negative. Fourth property, the arithmetic mean of the regression coefficient is greater than the correlation coefficient. That means BYX and BXY are the regression coefficient, and we are taking the average. BYX plus BXY divided by 2 is always greater than R. Because if A and B are in the arithmetic mean, then A plus B by 2 is called arithmetic mean. Therefore, BYX and BXY is the regression coefficient, then their arithmetic mean will be BYX plus BXY divided by 2 is always greater than R. Therefore, we have the relation BYX plus BXY by 2 greater than R. R is the coefficient of correlation. Now we shall take the angle between the two regression lines. If theta is the acute angle between the two regression lines of the two variable x and y, then we have to calculate tan theta between them is denoted by 1 minus r square upon r sigma x sigma y upon sigma x square plus sigma y square, where r is the coefficient of correlation, sigma x and sigma y are the usual meaning, and significance of the formula r is equal to 0 or r is equal to plus minus 1. Let us take the proof of this. First we are taking the regression line of y on x. That means y minus y bar byx x minus x bar, that is the value of byx. Similarly, x minus x bar bxy y minus y bar, and that is the value of bxy. That is the byx is the regression coefficient of y on x. Second is regression coefficient of x on y. Now let us take the slope between them. Byx is denoted by r sigma y upon sigma x. That is, let us take m1. Similarly, bxy is equal to r sigma x upon sigma y, and that is called m2. Then we have to establish the relation between them. Tan theta is equal to plus minus m2 minus m1 upon 1 plus m1 m2. That is the relation between slope between them. And we have to putting the value of m1 and m2 from these relations and establish the relation r sigma x upon sigma y, r m2 r sigma x upon sigma y, and 1 plus sigma x square upon sigma x square, and putting these values after calculation, we have the established relation 1 minus r square upon r sigma x sigma y upon sigma x square plus sigma y square. R square is less than 1, then sigma x and sigma y are positive. Then we have the relation positive के लिए tan theta is equal to 1 minus r square upon r sigma x sigma y upon sigma x square plus sigma y square. If r is equal to plus minus 1, then tan theta is equal to 0. Theta is equal to 0 or pi. If tan theta is equal to 0, that means theta is equal to either 0 or pi. That is a perfect correlation between the regression line and coincide the parallel to each other. If we take r is equal to 0, there is no relation. That means tan theta is equal to 0. Tan theta is equal to infinite. And theta is equal to pi by 2. So no relation, correlation between two regression lines is perpendicular to each other. That means 1 plus m1 m2 is equal to 0. That means m1 m2 is equal to minus 1, and that is become pi by 2 for perpendicular. Now let us take the example for the regression coefficients are 0.8 and 0.2. That means let us take byx is equal to 0.8, bxy is equal to 0.2. Then byx and bxy is equal to r square. That means 0.8 into 0.2 is equal to r square. R is equal to 0.16 under the root. R square is equal to 0.16. And that is R is equal to 0.4. In the both the regression coefficient byx and bxy, therefore R is equal to 0.16 and that is calculated as 0.4. Now let us take the linear regression coefficient from the following values of x and y. X and y are given as x and y are given as x having the value 1, 2, 3, 4, 5, 6, 7, 8. Y having the value 3, 7, 10, 12, 14, 17, 20, 24. We have to establish the relation and we have to calculate regression coefficient of y on x. Regression coefficient of y on x is given by n summation xy minus summation x summation y and summation x square minus summation x ka whole square. Here we have to calculate summation x, summation x, y, x and y, then summation x square. यहाँ पर calculation से summation xy, summation x square is to be calculated. N is the number of terms, 3, 3, 6 or 2. Now x and values are given as 1, 2, 3, 4, 5, 6, 7, 8. Summation x is become 36. Y is given as summation y is become 107. Now we have to calculate x square. X square means 1 ka square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 36, 7 49, 8 64. Summation x square 204. Similarly y square 3 ka square 9, 4 square 7 square 49, 10 square 100, 12 square 144, 14 square 196, 17 square 289, 220 square 400, 24 square 575. And the value of summation y square is 1763. Similarly, x and y are given as the value 519y. So x and y is to be calculated 1 into 3, 7 into 2, 3 into 10, and we have to find out the value of summation x, summation y, summation x square, summation y square, summation xy, and putting these values in our relation. Byx, n is equal to 8, and putting the value of byx 5 into 599 minus 36 into 107 upon 8 into n summation xy. N is 8, summation xy is 204 minus summation x 36, summation y 104, 107 divided by n minus summation y का whole square 1763. Sorry, summation y का whole square means 107 का whole square. 107 का whole square. whole square, and calculated the value in this series, that is become 2.79. Similarly, putting the value of bxy in this relation, the values become 0.3540. Now byx and bxy is to be multiplied to calculate r square, the coefficient of correlation, and that is become 0.9765 and r is 0.98. That is nearly equal to 1. That is a strongly correlated. The following table of the values of x in the years of cars and the maintenance cost of y are in the 100 rupees. X and y. These are the example. X is the 1, 3, 5, 7, 9. Y having 15, 18, 21, 23, 22. How much the maintenance cost? That means we have to relation byx, y minus y bar, byx, x minus x bar. We have to find out the value of x and y. Putting this value, x is equal to this, y is equal to this, summation x is become 25, summation y is become 99, and x and y, summation xy is equal to 533, and summation x square is equal to 165. We are not calculating the y square because we have to calculate here y byx, and byx there is no need of x square, not y square. Putting this value, n is equal to 5, number of terms are 5, sum x bar is equal to summation x by n, summation 25 by n, sum x bar is equal to summation x by n, yani 25 by 5, that is 5. Y bar is equal to 99 by 5. Putting this value, and byx is equal to n summation xy minus summation x summation y and summation x square minus summation x ka whole square. Putting this value, y minus y bar, byx, x minus x bar. Here x, y minus 19.8, 0.95 is the calculated value of byx, x minus 5. He wants to find out the value when x is equal to 4. That means when x is equal to 4, so y minus 119.8 is equal to 0.95, 4 minus 5 yani ki minus 1. And that is become x is equal to 18.85, 100 rupees. And that is, so we have the calculated the value of x corresponding to x, y is given. If x is given, y is calculated, then we have the relation of y minus byx, x minus x bar. If y is given, x is to be calculated, then we have the relation x minus x bar, bxy, y minus y bar. These values we have to establish our relation to establish them. Thank you. From my side, I have completed this lecture of regression analysis. Thank you very much.